Hello, PreCalc. It is our October, last day in October edition. So that is, let's see, 10, 31, 16. So you'll be watching this after class sometime on Monday, and we'll be calling it Solving Trig Equations. Solving trig equations. So we're going to take some of the expressions we've been using in verify and simplify problems, and we're going to have equal sign in them because it is an equation, and we're going to look at what values for a given variable the answer would be to make the equation true. For example, write the first trig equation down. Sine x plus the square root of 2 equals minus sine x. And we want all the values of x. So that's going to be an angle. All the angles that we take the sine of it and add the square root of 2, it'll equal minus times the sine of that angle. So we're looking for all the values that make that expression true. So we're going to need our unit circle. So let me try to draw a circle, and we only need part of it at a time. Sorry about that. Use your imagination. So let's the ones that I'm going to need in this portion is the quarters. So this was pi over 4, 1/4 pi, 2/4 pi, 3/4 pi, 3 pi over 4, 4/4, 5 pi over 4, 6/4, 7 pi over 4. And do you recall the coordinates to get from the origin to this spot? You go over the middle guy and up the middle guy. So the first coordinate was square root of 2 over 2, and positive square root of 2 for the second, over, up. Here, however, to get to this spot, we went back square root of 2 over 2 and up square root of 2 over 2. So same values, different signs as we dance around the unit circle. So here it would be back, down, minus, and minus. Alright, dance over to here, and we have plus and minus.
Marvel?
Yeah.
What you doing?
Alright, so here we have the unit circle that's going to eventually help us with this first trig equation. So, to solve a trig equation, we're solving, we are going to get the trig expression by itself with the variable. So we have sine x here and negative sine x here. So I'm going to move this one over across the equal sign by adding a sine x to both sides. That will create a 0 over here. I'll write down add sine x plus sine x. I don't always write that step, but so this is just 0 here on the right. So on the left here we have sine x plus sine x. 2 sine x, and the square root of 2 is still there. To continue solving, again, I'm trying to get this by itself. I'm going to move the square root of 2 over by subtraction, and I have equals negative square root of 2, and then I'm going to divide both sides by 2, and I have accomplished getting the sine x by itself. Sine x equals negative square root of 2 over 2. Alright, so I have solved partially by getting the trig function, which contains the variable x alone by itself right there. So now I'm going to find all the values for x, because that's what solve really means, is find the values for x. So where are there angles that have a sign that is negative square root of 2 over 2? So that's what I'm interested in now, all the x's that cause this to happen. So the sign is the second coordinate on the unit circle. So where do I find a second coordinate that is negative square root of 2 over 2? Not here, because here the second coordinate is positive. Not here, the second coordinate is positive. Here's one. So one of our answers is 5 pi over 4. But before I go and find another one, remember I want all the answers that make this statement true. I know that I am not limited to starting at the starting point and coming around to 5 pi over 4. What if I don't stop there? What if I go around again? So then I have another answer, and that would be 5 pi over 4 plus, how many radians is it to go around an extra time? Once around the unit circle is another 2 pi radians. But what if I don't stop there? What if I go around again? Then I have this answer, 5 pi over 4 plus 4 pi. I went around, 4 pi. And what if I go around again, it'd be 6 pi and so forth. So I have a way, and this will go on forever, because I can spin and hit 5 pi over 4, 5 pi over 4 plus 2 pi, 5 pi over 4 plus 4 pi, 6 pi, 8 pi. So I can go forever, but I have a way of writing all of these values by calling this first one 5 pi over 4 plus, let me get rid of these so you can see the magic clearly. Alright, 5 pi over 4 plus 2 pi n. And everyone knows who watches that answer that n means an integer, but I'm going to multiply times 2 pi. So 2 pi times 1, 2 pi times 2, 2 pi times 3, so forth. So that generates my 4 pi and my 6 pi and my 8 pi. So this will always generate, if you're going one whole circle around to get extra values, you can always do 2 pi times n. And we're adding that to 5 pi over 4. Alright, so that's one answer. Now let's look and see if there's another one, because way back here, we were looking at where the value x is negative square root of 2 over 2. We found one here, but is there not another one right here? So that was 7 pi over 4. And just like I did with the 5 pi over 4, I also know that the same value would work in this equation and give me negative pi over 2 if I went around an extra 2 pi, another 2 pi, another 2 pi. So I'm going to include all those infinite number of answers in this statement. 7 pi over 4 plus 2 pi n. So you have just finished your first trig, solving your first trig equation. If we put any of these answers back in the original, it will create a true statement. So that is very snazzy. So we're going to look at another one on the second video. So just pull it up. So bye for this one.